those initial notes are regarding the reasons why one or another energy system may be dominant during a particular physical activity or exercise. What we're going to look at now is something that's very important that often comes up in SACs and exams as a question, and that refers to the energy system continuum. So this is a graph that is very, very common for you to see as an exam question. It's also a really easy way to introduce yourself to the three energy systems and how they work in a graphical sense. So what we need to understand here is that this graph only makes sense for these three energy systems when we are looking at a maximum intensity exercise. So this athlete has gone for a run, a swim, a cycle, whatever it might be, at a very, very high intensity. They're actually working at 110% of what the maximum amount of oxygen that their body can bring in and use. So they are working above what their body's capacity is able to withstand. So what we can see here is that the energy demand is very high. The body needs energy to put ATP back together very quickly because all of the stored ATP is gone. All of the ATP is being put back together so that the muscles can continue to move. So let's have a look at this system here, the ATP-PC system. The ATP-PC system is the initial, the first out of the three systems to hit a peak and to provide the body with the most amount of energy after only a couple of seconds into this high intensity exercise. So the athlete who's gone very, very quickly right out of the gates, the majority of their ATP is being resynthesized using the ATP-PC system, which we'll get to a little bit later on. The ATP-PC system doesn't last very long because the stores of PC, phosphate creatine, run out in the body very quickly. So you'll notice that the energy being produced by that system drops off quite rapidly. It will never hit zero. It will always continue to work very, very small amounts in the background. However, the next system that becomes the peak in these three systems in producing energy for the body is, as I said, the lactic acid system. Now, this is what we need to refer to as anaerobic glycolysis system. The word lactic acid system is no longer accepted. It's an easy way to remember what the system does and what it produces. However, we need to refer to it by its official name. So now that we've essentially run out of phosphate creatine, what ends up happening is we start breaking down glucose, which was stored as glycogen, which was eaten through the carbohydrates prior to exercise. We start breaking that down, but our body is still only 25 seconds into exercise, and we know that at this high intensity, we haven't reached our maximum breathing rate, the respiratory rate, the heart rate. That's all still climbing. That's going to take a little while to get to that point. So this system, anaerobic glycolysis, is producing, for the most part. However, it's also producing some very severe fatiguing byproducts at the same time. Once we hit that point where we can manage to get enough oxygen down to the working muscles, our heart rate is high, our breathing rate is high, our VO2 max has nearly been reached. What we are able to do is make the aerobic system dominant. This system is still breaking down glucose and glycogen. However, it's doing it in a way where the intensity is never going to exactly be met. However, what we are able to produce is enough energy without a huge amount of fatigue being built up from that athlete. So if the intensity was to drop down a little bit and we were able to meet that VO2 requirement, when we're in that aerobic system, we're not going to be fatiguing. I'm going to flip over to a set of notes in a moment. And with that set of notes, what I would like you to do is to create your own set of notes on the 4 things that I'm about to show you. We're going to need to create a set of notes now. And the first thing in these notes, and they can go straight underneath the notes that you had, is that all three energy systems are always working to provide energy to resynthesize or put back together the ADP and inorganic phosphate back into ATP. And the reason this is important is because, as I've said many times, ATP is the only thing that can move a muscle. So if we want to continue to run, swim, cycle, jog, sprint, then we need to put ADP and P back together. We need to replace that lost energy and make it ATP again so we can use that bond, break it off, and use the energy. And hopefully by this stage you're starting to understand what that means. The next part of the notes is to create a very quick reference for yourself about the three main energy systems. So the first one, ATP-PC. The PC stands for phosphate creatine. I'll talk to you about that in a moment. This one here is for very high intensities, in which it will be dominant for the majority of the very high intensity, the 100-meter sprint. An explosive effort that's lasting 3 seconds, after 3 seconds, because the stored ATP will be for the first 3 seconds, and dominant for up to about 10 seconds, but depends on the person and how many phosphate creatine stores they have in their body. This puts ATP back together very quickly. So you're able to continue to sprint at a high intensity and high speed without noticing any drop off in your speed or your intensities, because the ATP is putting back together so fast from the ADP and P once it's been used. However, as I said, the amount of phosphate creatine we have in our body will be broken down pretty quickly and you'll run out of those stores. The next one there is the anaerobic glycolysis system. The word anaerobic meaning without oxygen present. This breaks down glucose, which was stored as glycogen from the carbohydrates we ate, and it's also being broken down when there is not enough oxygen present. So if you start to take note of your huffing and puffing and your heart rate during exercise, when you start to go for your run or your swim, your breathing is working its way up to where it needs to get to. In that working its way up part, we're not getting enough oxygen yet. So when we start to break down the glucose in the body to provide energy to put ATP back together, we're doing it without enough oxygen present. The problem with this is that it's still fairly quick. However, it produces some pretty fatiguing byproducts at the same time, meaning the longer I stay in this system with not enough oxygen, the more my muscles are going to fatigue and I'm not going to be able to last in my exercise. The final one is the aerobic glycolysis system, or the aerobic system, and I'll talk about the difference in a moment. Aerobic glycolysis talks about the breakdown of glucose to put ATP back together, and it has enough oxygen present in the muscle now. That's where the word aerobic comes into it. You'll notice that it's also referred to as the aerobic system, because when we spoke about food fuels, we know that fats are a fuel that we can use for exercise as well. So when we break down free fatty acids, or FFA, which is how fats or triglycerides are transported around the body, when we have sufficient oxygen, we can use this aerobic system to perform aerobic lipolysis, which is the breakdown of fats inside the body. This one can last for a very long time, and while it's working, unlike anaerobic glycolysis, it doesn't produce those fatiguing byproducts and make us tired. So why do we stop in this system? Usually because we run out of the stores from carbohydrates and fats that we ate, from the glucose and the glycogen or the free fatty acids around the body. So this one here will continue to work until we run out of fuels within the body. I'd like you to create your set of notes now regarding how all three energy systems are working together, and then a separate set of notes generalizing with no diagrams about each of those three energy systems like I just talked you through. Once you've done that, you can watch the next video.